Hello there. Welcome, everyone. We are so excited to have you join us here today for the 5th annual Charlottesville Women in Data Science Conference. My name is Arlen Burgess, and I am the Chief of Staff for the School of Data Science here at the University of Virginia. And happy Friday and happy Wids Day, as we say, one of our very favorite days of the year. We are so excited that you're tuning in to join us today. And we've got a really exciting lineup for you today, including speakers that are calling in from all over the country and some really, really awesome programming. Big thank you to our AV company that's making this happen for us today. A really fantastic opportunity. We'll talk a little bit more about that, about making this a virtual conference once again this year. You may recall, those of us that tuned in last year, our fabulous team actually pulled this conference online in a matter of days. This year we had a little bit more time to plan, but still in this virtual environment, and really thrilled that we have the AV company helping us out, making us be able to make this content even more accessible than we would be able to otherwise. So as I said, we've got an awesome day lined up for you here today. And a special thank you right from the beginning for our sponsors here that have made this possible. So we've got session sponsors and alumni panel and a tech talk that were sponsored by the Deloitte AI Institute for Government, Microsoft Azure, and S&P Global. Our fabulous closed captioning sponsor that's providing the closed captioning that you'll see throughout the entire conference today, Oracle for Research. And then a big thank you also to our general conference sponsors, which are Quantitative Investment Management, LMI, and Capital One. So our sponsors partner with us to make this conference happen. They really bring it to life. And beyond contributing, they also help us source speakers. They help us develop themes, really keep us live and up to the pace of things that we should be doing for this conference. And they make it accessible to all of our participants. So a big virtual round of applause, please, for our sponsors for making this possible. If you're interested in partnering with us in the School of Data Science, we'd love for you to take a look at our website or reach out to datascience@virginia.edu. Great place to get started, and we'd love to partner with you. We've got great opportunities for educational and research partnerships. I'd be remiss not to mention the time that we're living in right now, and the time that we've now gotten probably far too used to in the time of COVID. And I think that it's important that we note that never before has data science been so practical and so necessary. We're still living in this virtual environment, but it's incredibly important for us to be able to connect as a data science community and talk about ways that we can really think about moving the world forward, especially in a time when data is so incredibly important. And in this time of social distancing and isolation, it's also just really important for us to stay connected to one another. And so it's important for us to think about ourselves and our communities, but also to really think about the communities that have been most severely impacted by the state that we are in right now. And so I invite us to really think about ways that we can come together as a community and ways that we can really help our community move forward. I encourage you to take the time to learn today. I hope that you're getting to take some time to even though you're still looking at a screen, maybe taking time away from what you may be doing on a normal day and be able to learn and engage, have some dialogue and connect. And we're going to talk a little bit about ways to connect during the conference and stay connected both on social media and also through our platforms for asking questions and engaging with our speakers. In this time, significant research efforts have sprung up and they've expanded across the School of Data Science and the university, as well as more broadly about how data can help inform the way that we deal with something like a global pandemic. The School of Data Science is a new school at the University of Virginia, and we are really dedicated to thinking about these kinds of problems and how we can help move the world forward. As a school, we are growing fast, and we're really excited that we have all of you engaged and tuning in today. We're hiring, so we invite you to please come. We're looking for data science expertise across the board, and we'd love for you to take a look at the job section of our website. But as we think about growing, have a lot of really fantastic educational opportunities with the educational programs that we have currently, as well as things that we're expanding into, thinking more about different populations and how we can make data science more accessible to everyone. We also have an executive education, which is our education for continual engagement for all professionals. And we're really excited about launching some of these programs. And whether folks are new to data science or they're experienced data science professionals, our programs are really aimed to transform an understanding of analytics and enhance people's practical skills in order to boost their own career and become a more ethical manager of high-performing data literate teams. So really thinking about how we are engaging in data science across the board. So we welcome you to check out our website for more information about the virtual sessions that are coming up in that arena. Specifically about women in data science, and you'll hear us call it WIDS throughout the day. It really is one of my very favorite days of the year, an opportunity to highlight women in this really exciting and innovative field. And the Charlottesville WIDS conference is a part of the Global WIDS conference, which is started out of Stanford University, and they had their major event earlier in March. And we're excited to be connected to all of the exciting things that the Global WIDS group is doing. Here in Charlottesville, this is our 5th annual WIDS event, and we've been growing, and we've had fantastic speakers throughout, and this year is no exception. And this year we have almost 650 registrants that have signed up to join us today. And just as an FYI, registration is not necessary in order to tune in. So please send the live stream link to all of your friends. Tell them to tune in. We've now pointed our registration directly to this space. We have folks tuning in from all over the country. We've got people in Alaska, California, Texas, Minnesota, and obviously here in our Virginia region and right here in Charlottesville as well. The reality of this is we wouldn't have been able to accommodate this number of people or this diversity of people if we had been on grounds in Charlottesville. And so we're excited that this virtual opportunity has also given us this opportunity to make the conference more accessible. As I mentioned before, it's incredibly important that we stay engaged. And there are a couple of ways that I wanted to let everyone know that they'd be able to do that throughout the day. So we are live on all of our social media platforms, and we invite you to use hashtag 2021 Charlottesville WIDS, WIDS, and using that hashtag to engage with folks about this conference. The school's Twitter handle and Instagram is @UVA Data Science. We invite you to ask questions and engage with each other. Invite people to see what it is that we're doing and invite them to come join us on social media throughout the conference. Specifically for our keynote speakers, as well as our panel on AI in the public sector, we're actually utilizing a platform called Poll Everywhere. And there's a button directly below the live stream link that you're looking at right now that invites you to ask questions to our keynote speakers throughout their talks. So if you just click on that button, there's an opportunity for you to go in, ask those questions. We'll push them forward, and there's opportunities for you to upvote, give our Q&A folks the questions from the audience to really be able to engage with these speakers. So every time a new panel or a new talk starts, the questions will be the option will open. So while our speakers are doing their talk, please feel free to ask a question at any time, and then we will take a look at those questions and engage with them at the conclusion of those talks. Another way to do that, again, use that button, or you can just go to pollev.com/CVille WIDS 2021. So again, that's linked directly in the box right below where we are. So with all of that, it's fun for me to get a chance to say hello, to greet all of you, to get you as excited as we are here at the School of Data Science for Women in Data Science, Charlottesville 2021. That leaves me with the pleasure of introducing our first keynote speaker, which is Dr. Christine Borgman. So Dr. Borgman is a distinguished research professor of information studies at UCLA, where she conducts research in scientific data practices and information policy. She is the author of more than 250 publications in information studies, computer science, communication, and law, which include 3 books from MIT Press, Big Data, Little Data, No Data, Scholarship in the Networked World, which was the winner of the 2015 American Publishers Award for Professional and Scholarly Excellence, the PROS Award, in Computing and Information Sciences, Also, Scholarship in the Digital Age, Information Infrastructure and the Internet. And finally, From Gutenberg to the Global Information Infrastructure, Access to Information in a Networked World. At UCLA, Dr. Borgman directs the Center for Knowledge Infrastructures, where she has received funding from the Alfred P. Sloan Foundation, the National Science Foundation, Microsoft Research, and other sources. She's held visiting scholar positions at the Harvard-Smithsonian Center for Astrophysics, the Harvard Data Science Initiative, and the Berkman Klein Center for Internet and Society, amongst others. She'll be joined later by Dr. Michelle Claiborne, who's the faculty director and lead data scientist for the democratization of data at the Equity Center here at the University of Virginia. And Dr. Claiborne will moderate the Q&A with Dr. Borgman as soon as she finishes her talk. So don't forget to submit those questions as she's talking and there at the end. So we're so happy to have you here, Dr. Borgman, and calling in from California. So good morning to you, and take it away. We're excited to have you.
Good morning. Good morning from a sunny Los Angeles. It's indeed a pleasure to be here in this exciting set of conferences and to engage with my many good colleagues at the University of Virginia and Charlottesville as well. I've enjoyed others of these WIDS conferences, and they've tended toward the technical and the ethical issues of data science. And my interest is in the social science aspects. So I thought that would be a good way to complement some of the other things that you've been hearing about. And as Arlen said, I spend most of my time working with scientists. So I'm going to focus there to keep this where we can get into a good set of topics. So this is where I want to start, is when you think about the sciences, and I've been working primarily lately with astronomers, but I'm going to take you on a wander across some of the environmental sciences and deep ocean science. Of course, deep knowledge intensive area that can be difficult to are most focused on about how you make data useful and reusable. Scientific data in principle are useful for very long periods of time. And we're going back decades and sometimes centuries and reusing data from Galileo's time. The rest of these questions really cascade from there about how you decide what's worth keeping, how you deal with some of the economics and governance issues that I'll touch on, the stewarding the data resources, and the very difficult economic and technical one about who pays for all of that infrastructure. This background, I think for those of you who are not familiar with the research enterprise or not, say, faculty or actively engaged in getting funding, for the last couple of decades, we've had progress across the world. It started more in Britain and in Europe than in the US, but it's now really international. Whereas if you get funding from public agencies, from National Science Foundation, National Institutes of Health, and so on, you're expected to make the products of those works as freely available as possible. And that started with open access to publications. It's gone heavily into open data. During the COVID period, we've seen a real ramping up of data sharing and open platforms, much more work in open software and in preprint servers. That didn't come out of nowhere. That came out of these couple of decades of work to lay the policy foundation, lay the infrastructure foundation for improving data sharing. But how do you actually do that? The most obvious thing, what people try to do first, is link data sets to a journal article or publication. That leads us to the question of where you put those things that you're going to link to. If you have an archive in your field, and I've scattered this screen with a few different ones, you can put it there if you're in the earth sciences, in genomics, in planetary data systems. If you're doing social work that covers surveys, you could put it in ICPSR, a number of different places you can put it. But the number of archives, domain-specific archives, is far fewer than there are the kinds of data that is out there. Then there's a question about making usable how you publish the documentation about it. If it's big science, if it's the Hubble Space Telescope or the Linear Hadron Collider, you've got really industrial strength capacity behind it, and you're going to get the sort of robust industrial quality documentation. But most science happens on a much smaller scale, and you just don't have that level of robustness in terms of documenting research software to keep it useful for a long time. Citing data and software so you can find it again is a piece of this. That's worth a whole nother talk in of itself, as Michelle well knows. So I'm going to set that one aside, and if you want to come back to it in the Q&A, we can. Linking data and publications is a start, but it doesn't get you a coherent kind of collection you can get back to, because it's not a one-to-one mapping. It's many-to-one, and it's one-to-many. People will do research over long periods of time, and they will slice and dice those data, ask different questions, recombine them, reintegrate them. So that is far from a permanent solution or a comprehensive solution to getting back to those data and resources for reuse. The FAIR principles, which again, if you're working in the area of open science, would be very familiar, are now 5 years old. They've been widely promulgated, widely adopted, and particularly in Europe, you've got big investments in implementation practices around these. Now notice it's findable, which means there's a way you can describe it and search it. Accessible, which means they're open and available. Interoperable, that's a real challenge, because are we talking about a data set being interoperable with this year's software, with a version from a year ago, with a version from a decade ago? And then the data should be reusable. I'm going to come back to that several times about what reuse might mean. And notice also that the bar is reusable. It's not about being reproducible, and it's not about being replicable, verifiable, many of the other things that you find in scientific challenges. So that's the ideal. That's where we're trying to go. In a perfect world, that's where we would be. However, this is really more where we are most of the time. The 404, which you don't run across as much lately, they tend to be hidden. That simply means the resource can't be found. And NASA actually does have a sense of humor. This says the cosmic object you are looking for has disappeared beyond the event horizon. What that really means is you've gone over the edge of a black hole, and if you've dropped into the black hole, it's never to be found again. And in some sense, that's the state for much of data. It disappears into black holes. If you don't keep it up, if you let the software fade, if you redirect it to other platforms, pretty quickly data are going to go away just by sheer benign neglect. And that's what the no data means in the book title. So let's talk about what those data are in the first place. We have been asking scientists and social scientists, actually people in the humanities as well, questions like, what are your data? That gets a surprisingly head-scratching set of responses. People don't agree on what are the data. This is a real signal to noise problem. One person's signal is someone else's noise. Those various policies that require you to deposit data don't actually define data. They leave it pretty much to the beholder, other than putting up examples of, is it the raw signals coming off the instrument? Is it the process data coming off the pipeline? Is it the figures that are in the paper? Is it the tables that are in the paper? We have lots of numbers like these ones from Cassini I've got in the upper left corner. But what does it mean that you've executed 2.5 million commands? What does that tell you about what the data are? The number of papers published is nice, as are the number of moons that are discovered, but those numbers aren't the data. Rather, this is where I ended up with in the chapter, I think it's chapter 2 of the Big Data, Little Data, No Data, is simply what are data? And that's where I landed on this phenomenological definition that says something becomes data when you use it as evidence of phenomena for the purposes of research or scholarship. So one person's evidence is somebody else's noise, and we see that all over the different sciences. And I'm going to walk you through some different examples from the research that we've done over the years. Let's start with CENS, Center for Embedded Network Sensing. This was a very large computer science and engineering center funded by NSF for 10 years. Deborah Estrin was the principal investigator for this. She later won a MacArthur Award for this, and later work she's been doing in the medical sciences since. About 2/3 of the partners in CENS were in computer science and engineering, and the other third were mostly in science and application areas. I was one of the founding co-PIs and interested in the data all the way through. They're coming together to invent new kinds of technologies to do new kinds of science. So the scientists were interested in getting computer science to help them build new tools that could get them far more discrete, broader kinds of sensing data about the environment. And the computer scientists and engineers wanted real world applications. So it was, a very fruitful set of collaborations that went on. And we wanted to help them manage their data in ways that they could use it across this multidisciplinary center. And my students, I've got a number of dissertations and postdocs out of this project, would get embedded in these groups. One student fell into quicksand working with one group. Another one got altitude sickness laying a transect for seismology across the Andes. We really got down and dirty on working with them. And that allowed us to see how the science was happening, how the data was happening in ways the scientists and engineers didn't themselves. This particular engineering researcher working on robotics was concerned with whether the team's sensors were getting the same data from one day to the next. Was it consistent? And temperature tended to be a variable that crossed many of the different experiments that they were doing. They had a lot of breakdowns, a lot of battery problems. If he got the same reading from one day to the next, he had data. The biologist on the same project, working side by side with him, could not publish the data that came from those robotics team because those weren't data to him. In his world, he had to compare those sensors to something else that met an international standard from CODATA. And he also set up other sensors side by side for 365 consecutive days before he would trust the data that came from these experimental sensors. So this is where you really see that kind of signal to noise. They're both correct. They both have publishable data with respect to their fields, but they're seeing very, very different things in what's out there. Let's move on to another project, another NSF Science Technology Center that overlapped and ran from 2010 to 2020. That was also founded. It was a PI of a woman, Katrina Edwards, who we've since lost, a very large one. And this is an international drilling platform where they would go out into the oceans around the world and drill these deep sea cores under the ocean, bring them up, and then store them in repositories like this here on the right. Peter Darch did most of the field work as a postdoc on this project as part of our team. This one is signal to noise in a different respect, in that those deep cores that they had built, that the data came from those, they could be extracted in different ways. They would do some kind of data collection analysis on the boat itself, because this was built for physical science data, and the microbiologists we were working with came along a decade or more after the whole infrastructure was in place. They would split that core, and to do the physical sciences, the geomorphology, the chemistry, and so on, you could store that core at -4 centigrade. To do the microbiological work, you had to store it at -80 centigrade. And -80 freezers were something that nobody outside this field really knew about until we started dealing with the Moderna vaccines and the Pfizer vaccines that have to be stored at this level. And that's fairly common in this kind of work. But the point here again is that decisions that are made at the very beginning of that scientific process about whether it's going to be stored at -4 or -80 determine forever after what can be done with those data. Now let me spend time on the practices around all of this, the data handling, the aspects that lead to whether these things are really useful or not. This is the librarian's view of the world. This is the virtuous circle of, in the best of all possible cases, you do your research, you build it, you publish it, you preserve the data, you reuse it, and it goes back around and around and around. Beautiful circle. This is an image from the UC Irvine libraries, and it was also published in a short piece on just the whole notion of life cycles and data that I put in the inaugural issue of the Harvard Data Science Review. And I want to give a shout out to the HDSR, which just won the Prose Award this year for the best new science journal. And it's a very broad interdisciplinary journal. And I'd recommend it to you both as readers and as authors, as a place looking for a really broad integrative set of papers around the data sciences. Part of the challenge on getting data into that virtual circle is the sheer lack of incentives to share data. These by now are well known. Most of one of the chapters in the book is devoted to that. It's a lot of work to document those data in ways that you can make them truly accessible for somebody else to use. And how much work do you want to put in to make data useful to somebody else who might be able to find things that you couldn't find? Okay. The economics are pretty messy in here. Also, really doing archival work on data is the work of archivists, not necessarily the work of the scientists per se. So getting the kind of partnerships to deal with the sustainability is one of the practical issues in the sciences in terms of maintaining access for the long term. This is the reality. Okay. This is who takes care of those data in most of the sciences. Would that you could stick that Ethernet plug straight into the cloud and have things taken care of. Even there, it turns out the cloud is better for computing than for data storage per se. Everybody has legacy data. These are just a few of my favorite snapshots of things that you find in back rooms. The grad students and the postdocs are the ones who are doing most of the data capture, the data management, the data storage, and really writing most of the research grade software, unless you're in the really big industrial size projects. So this notion at the top of getting a hammer to migrating data from one system to the next, this is what integration and interoperability usually really looks like on the ground. And that's certainly what we see across the different scientific projects that we're working in. So infrastructure, that's kind of the big picture. And that's why we call this the Center for Knowledge Infrastructures. And again, there's a good chunk of literature on knowledge infrastructures that we could point you to. This is the set of 8 dimensions of infrastructure that were promulgated in the mid-1990s by Lee Starr and Karen Ruleter, and they've been used in many ways in many places. And we don't have time to go into the detail of them, but let's just note that they can be placed along these dimensions of global considerations to local ones, and from the more technical ones to the more social ones. They embody standards, those interoperability issues, the installed base. What are you building in terms of data formats and standards and principles and software that you use? Infrastructure is often invisible until something breaks down. You didn't know you had an electrical grid. You didn't know you had other things until it doesn't work anymore. Link with conventions of practice. It's easier, and particularly data science and the sciences, to look at the global and technical and let the social and the local kind of disappear in the background. And I want to make that contrast between global and technical and the local and the social here. The global and the technical are these things that you build. You can see them, sometimes you can touch them. There's software that you can run. It's those data archives, it's that instrumentation. It's all of those pieces. And that's where the funding is. You can see line item budgets for those. But they happen over very long periods of time. And that's one of the things that have been fascinating about working so closely with my colleagues in astronomy. Look at the period of time over which these projects occur. The Sloan Digital Sky Survey, conceptualized in the mid-1980s, began construction by the late 1980s. The first light came, I think, 1998, and it's still collecting data. Actually, it's now into phase 5, which is going to run to 2025. And one sky survey then lays the groundwork for the next sky survey. The LSST, the Large Synoptic Survey Telescope, has been underway again since the late 90s. They commission these things, start thinking about them just at the beginning. When the previous one gets first light, they're laying out the plans for the next one. How do you plan hardware and software over multi-decade periods like this? Well, what happens is you have to freeze the technology and freeze the data structures very early on. This is about as far from agile computing as you can get. And yet it's the real state of data science in the large science projects. The smaller science projects are much more agile, but in these big ones, it's not. But they produce very important data that remain useful for huge periods of time. Now, here's an example of the kinds of infrastructure built within astronomy. VAO in the middle is the virtual astronomical observatory. On the left, you can see technical links between the observations coming off the telescopes and the actual objects. The objects would be Jupiter and Mars and Sagittarius A star, which is the black hole in the center of the Milky Way. NED and SIMBAD are two large databases and resources that bring them together. Similarly, the objects themselves are linked to the publications through NED and SIMBAD, and the details aren't important here. But over on the right, getting those observations and the publications, if I want to see where these observations were done and match them to publications, that's where you've got the librarians coming in, you've got the archives, the different missions coming together. A lot of people work, especially over there on the right. You can also look at these infrastructures, and astronomy has the most elaborate of any of the fields that we've looked at, in terms of different kinds of public-private partnerships. You could flip this around in many different ways, but putting the astrophysics data system in the middle, and notice it started in 1993. It's approaching a 30th anniversary with a lot of continuity. I think Alberto Akamatsu it's been there since the very beginning. But ADS has data flowing to the major observatories. It's working with the major publishers in the field. It's got links back to repositories and to the virtual observatories, the libraries, the Worldwide Telescope, Google Scholar, and is able to pass data. It's a real infrastructure component piece, but not many fields are able to do this. In fact, we haven't found anyone who's been able to do it at the level of completeness that astronomy has. It's a local and the social where things break down and are harder to get accomplished. I can't tell you how hard it was for me to find a picture of a data scientist with a woman in it. but it makes a nice little clip. Took a while. Although, well, we won't say about the cute little skirt, but that's what we've got for the woman data scientist here. Metadata really is a love note to the future. The work on metadata and provenance and interoperability, this is where the rubber hits the road of being able to use the data. And it's absolutely not a case of if we build the archives, they will come. The archivists spent a lot of time recruiting data, managing, packaging, making those data available, and getting them in and doing the kind of maintenance it takes to keep these pieces together. This one's a little complicated, but let me give you the high points here. And again, point you to the paper, which is also in the Harvard Data Science Review. We brought together work from our 10 years with the Center for Embedded Network Sensing and Environmental Sciences and the data from Irene Pasquetto's doctoral dissertation in biomedical sciences to look at what kinds of data reuse was really going on, build on some earlier work we've done at SENS with Gillian Wallace and Lizzie Rolando as well. The comparative data reuse is fairly common. That's what people do on an everyday basis. You'll go and you'll do a data review like you'll do a literature review and say, ground truth and calibration, does my data match somebody else? That's pretty straightforward. It's this part on the right, the integrative data reuse. This is the ideal where things like the FAIR principles, the open data principles are trying to go, is can you reuse those data to ask new questions? And that's what we'd really like to do, is ask new questions out of them. That is much, much harder to do. And we found it to be a very rare practice. It's an emergent practice. It requires different kinds of knowledge. And again, we did a deep dive into the kinds of knowledge that was required, the cognitive science piece of it, for comparison. One of the things Irena found in her dissertation is that when the biomedical scientists want to reuse somebody else's data for asking a new question, the piece of metadata they most needed was not in the record, and that was the phone number of the PI. Not part of your usual metadata structure. They need to talk. And that's where we ended up calling this the data creator's advantage. No matter how well you document, how much metadata, the people who were involved in creating those data in the first place are always going to have the most intimate knowledge of them. So let's kind of begin to wrap up here with some of the issues around infrastructure and durability and fragility. Durability is an accomplishment. The normal state of things with infrastructure is fragility and even with brittleness. The parts of infrastructure we found that are more durable are ones where you've got international coordination, you've got investments in long-term value of particular kinds of data. They've been able to agree on standards, and the physical sciences have more consistent units of measurement than the biological and the life sciences do on data structures, and where they're able to have shared resources. The FITS files, which is the standard data structure in astronomy, was laid out in the late 1970s in Fortran, and it's still the installed base that lets you bring data together from decades and pull them together. And we're seeing new tools, new models still being built in Fortran that run on those data sets. If we compare that to what some of the fragility is, and the fragility is really everywhere, and surprising differences you might find if you're not, sort of really down embedded in these, is where the investments are made in the data stewardship by field. One of the things that became apparent, it probably took us a while, we've been working with astronomers for 12 or 15 years now, is that the space-based missions, if you going to Mars, you've got the James Webb, you've got the Hubble, the Chandra, those are very large, expensive missions, and they build the data archive into the initial mission budget. They're committed to keeping those data available long past the time of active data collection of the instrument. And that's not true on ground-based. When you look at the Sloan Digital Sky Survey, for example, we've done several studies of what they've tried to do to keep those data alive. You get funding for keeping the data for as long as you're bringing in new data. But at the end of it, there's not a lot of funding for keeping them accessible and available so that other people can reuse them. It's been a constant scramble. And you get differences in kinds of instrumentation, what kinds of access to the data. Sometimes it's public archives, sometimes it's local data, local websites. A lot of data that's just sitting on people's local team websites. And as long as they're there, as long as they've got a webmaster, it's there, but may not stay there. And they also invest differently in curation. Astronomy with others is moving toward Python and open source tools and away from the big proprietary investments, but they're thinking about how does that change the community structure in terms of governance and commitment to keeping these alive. We've got a paper that's out in review on just the issue around the pipelines and how the pipelines vary from one kind of science within astronomy to another to keep these data alive and keep them useful. So let me summarize with a couple of last slides, because I want to leave us plenty of room for discussion with the audience and with Michelle. Okay. So to bring this all together, to think about scientific data and infrastructure is to say that at the bottom line, infrastructures are fragile. They break quickly. They are very much subject to software collapse, where one piece breaks, everything below it drops down, and you're in big trouble, and you might be in big trouble on your precious night on the mountain too. So lots of background work gets done. The visible parts of the infrastructure are those instruments and the institutions, but the invisible infrastructure is this information work. A lot of papers written on that by now, but it's that invisible work, the work that Michelle and her team have done at the UVA libraries, it's done at libraries around the world, at data archives around the world. That information work is what keeps these data alive and keeps them going. And no matter how global the science is, the practice is very, very locally. You can walk into somebody's offices, ask them how they keep their data. They'll tell you, oh, we do it just like everybody else does. They'll tell you how they do it. You walk next door and they'll say, we do it just like everybody else does. And it's completely different from one office to the next. It can be surprisingly idiosyncratic, the way that it's done. So data infrastructure and stewardship, big questions of whose data are we really talking about. You've got global data like astronomy. You'd like to be fungible. You'd like to be comparative. But there's a lot of deep dive idiographic data that are highly specific to situations. The data in SENS, what happened on one little square, one little plot of land was different than what happened on another little square and another little plot of land. When do you want the deep dive? When is it reasonable for them to be comparative? They don't always need to be comparative. They can't be. Whose infrastructure? The funders are doing some kinds of infrastructures, but many of the funders are not willing to be that broad-based infrastructure. They want to fund one project at a time. They want the universities, they want the investigators to build that infrastructure. They want the companies to build that infrastructure. But individual investigators are finding themselves with really big data problems. They're getting, individual investigators are getting terabytes a day from some of these projects, and managing them is a real challenge. Which leads us to whose stewardship. And this is where there's debates around the world. Different countries, different governments, different funding agencies are thinking in different ways about it. Is who's going to maintain the collections? Who's going to maintain the models, the climate models, the Monte Carlo models? Who's going to maintain the instruments and the technology and the code? And if you got the instrument, but you don't have the code, you don't necessarily have the data either. So we need to invest in the people and the skills and in the collaborations. And speaking of that, there's been a very large and long collaboration. This is just a few pictures of people who've been with us the last 10 years or so. And we've got elaborate websites with various other people. And we publish our publications openly. We have pretty much everything in the University of California eScholarship repository, and they're linked from our websites. We try to be as transparent and as open in our science as we possibly can. So Michelle, I think we've left, almost half an hour for questions and discussion.
Fantastic. Oh, thank you so much, Dr. Borgman. You've given us, a wealth of dimensions and components to think about. And
I actually kind of want to, while we wait for some additional questions to come in from those gathered with us, I actually am going to take the prerogative as moderating this to ask first a question I would love for us to hear more about. And that's around the invisible labor that you reference at the end, right? You identify invisible work as a key feature of the current knowledge infrastructures, emphasizing the volume of labor necessary to document, organize, and manage scholarly information, including data, and the way that much of this labor is really, it's provided by information professionals, by software engineers, by librarians, by programmers, and technical experts working across an organization. And as you mentioned in the end, the kind of thing we tend to notice only when it's not working. So I would love to push a bit more at this invisible labor, as I think it raises issues both of sustainability and of equity.
Right.
And I think this invisible labor in an academic setting, which is the setting I'm most kind of familiar with and engaged in, also has some clear analogs in industry settings, which I think some of our audience are likely to be more engaged in, right? And here I'm thinking of things like the growing awareness of the work conditions and exploitation of M-Turkers, that is the gig workers on Mechanical Turk, who do so much of the data labeling and cleaning work that underpins machine learning and other data science methods. So kind of broadly, I was hoping you could say a little bit more about this invisible labor in academic or other settings, and in particular possibilities for more appropriately recognizing and compensating and supporting those contributions, like what that investment you reference might look like.
Well, definitely, it's an investment, and it's what the invisible labor is not exclusive to academia by any means, as you say. It's just that's where I work, and it's the area that I know best. We've seen that for a very long time as the infrastructure, as science has gotten more data intensive, to realize that there's a whole layer that's not being invested in. And it is, like you say, software architects as well as the archivists and the librarians. And these people tend to be paid much less than comparable jobs in industry. So universities are, finding themselves training up people on what we call soft money, grant money. And as they get to be highly skilled and really know the domain, they get snatched off by large companies who pay them far more. And there's a real turnover in academia, which makes it even harder, I think, at this end to keep them going. We find also the maintenance work is one that's undervalued. The people who do the calibration, who keep those pipelines running, who make the interoperability actually possible, tend to be undervalued. And often in the sciences, these are people with PhDs in the sciences. They've got PhDs in astronomy, in astrophysics, in geosciences, seismology, chemistry, you name it, genomics. And there's, I think, 10 to 15% or so of those PhDs will get faculty jobs. And many of the rest of them are going into this kind of research infrastructure work. And often they're kind of almost temporary labor because they're going from grant to grant. And yet, if you don't keep them going, and if you've got a gap of several months between grants and you lose your people, you're just kind of hung for maybe a decade. And universities are seeing some of this and providing some transition funding, and you've got something the size of School of Data Science, you can do this. But I think it's certainly a labor piece that is being attended to and looking for new kinds of ways to invest in these people and recognize them. And let's not hope we have to have too many more big losses of major data sets or collapse. I mean, Arecibo collapsed. It was terrifying. Just absolutely amazing piece of infrastructure collapsed. They're still investigating, but it certainly appears to be lack of maintenance, lack of investment in some of these areas. So yes, let's highlight that across the different sectors, government, academia, and industry, as places to invest. The more data intensive we get, the more we need these people.
And sort of following on that, I know you in your broader work also talk about the greater variety of roles that have been developed around publications to better define and promote sharing credit with all those who've contributed to scholarly work. And so is that a model that we might follow for data science and data stewardship, having a variety of roles that we might better credit and acknowledge these contributions?
Well, certainly credit and acknowledgement, that's come a long way. If you see the changes, if I know this is a broad audience, this is not a majority of you will be authors. But for those of you who are authors, you will have seen a change when you submit an article for publication over the last few years from simply saying, these are the authors, this is the order, this is the corresponding author. Now we're being asked to say check a bunch of boxes. Who did conceptualization, who did writing, who did data analysis, who did visualization, and who was the lead and who had a greater or lesser role on some of these papers. So we're getting more credit there. We've seen this again in our studies where in some places, the people who build the instruments, build the tools, will get authorship credit. But in other places, they'll at best get an acknowledgement at the end of the paper. If they get an authorship credit, they're much more motivated to keep going on these projects. So that's certainly part of it. The challenge is that it becomes a Hollywood cast list after a while of what the authorship looks like. The sciences where you've got some of the Sloan Digital Sky Survey papers have 250 authors on one paper that describes the data release. Okay. And so getting down to who did what is pretty hard. The ones or the major breakthroughs from the Large Hadron Collider from CERN, the Higgs boson and so on, have 2,500 authors on them. Now, you certainly don't do those kinds of check boxes on the 2,500, but it also highlights some cultural differences from field to field of how you give credit for this kind of work. The Council Biology editors, which is very concerned about issues of fraud and replicability, requires every listed author to sign off for having read and verified everything in the manuscript. Whereas with CERN, some of those 2,500 authors are deceased. They're not signing off on manuscripts. And the culture there says we need to give credit for the people who helped develop this project, who built the instruments, who did the early grunt work. There's a lot of early service work. And the way to keep them motivated is to give them credit, even if the credit is 10 years later. Okay. So the notion of credit varies considerably from field to field. This is the local and the social of how these infrastructures work.
And I'm gonna pivot and relay some of the questions that we've gotten from our audience, and I'm going to combine a couple that I think touch on the same thing. And this is around the durability, thinking about the durability and the fragility of data and the need to maintain data for the long-term future. One question references, for instance, the work around the need around radioactive waste or hazardous landfills to maintain data for potentially thousands or tens of thousands of years. And yet the funding for data afterlives is limited, right? So how can we convince funders, or how could we advocate for more investment to do this maintenance, both for data reuse and the potentially long-term needs of knowing, what we've done to our world?
That is one of the scariest examples that's out there. Is where are those landfills? Where are those radioactive fills that we might be walking across and buried? In London, there's a flag of where the plague victims are buried. We know where they are, but do we know where the radioactive waste is over the last decade? Is something. This is again an argument for libraries and for archives. And the fact that you can go back and you can get the data, the sketches really from Galileo, that we can get back to some very early things beyond that, is a credit of the archivist who kept this. But you've got to get a public commitment to these. And I think it's also been a real challenge for libraries and universities and elsewhere, is what now the library is coming to you instead of you going to the library. The libraries are undervalued, and the work that's being done to make that library, make those resources come to you is even more invisible. And so it's saying, oh, well, it's just going to be there. And this is part of what groups like the Sun Digital Sky Survey are facing. Oh, you got the data. What's the problem? Why should we keep funding you? Well, somebody's got to keep those disks spinning. Somebody's got to migrate them. Somebody's got to keep the software up to date. Somebody has to have a help desk to go with them. And somebody has to have that building. This is the Powell Library at UCLA behind me, one of the original buildings of the campus. And somebody's got to keep that building open and keep it heated and air conditioned and cooled and dehumidified and keep the critters out of the paper, or it's not going to be there. So it's getting people, it's getting the society to recognize the long-term investment in the cultural heritage is also the long-term investment in things like the hazardous waste in the environment. It's an excellent example.
Thank you. And I feel like there's a thread here, and so I want to keep on this a little bit. You referenced again the local and social, right? And you've given us, you've really helped us think about the larger policy and coordination space needed to facilitate knowledge infrastructure, the consortia across organizations or at a national, international scale. But I want to dig into that local social level a little bit more, and particularly the very micro level, to consider how we gathered here in our roles as individuals or teams of data scientists could be good allies to and advocates for are often unknown to us collaborators maintaining this knowledge infrastructure. What can we do in our role often as users to promote the recognition and again, financial sustainability, because I know I keep coming back to it because it's such a big issue of this infrastructure, or otherwise ease the burden of this work for these collaborators, whether we know their names or not?
I would say, for starters, reach out to them, find out who they are. They may be somebody, over the transom, as we used to say. They're people in another room, they're another place. You don't actually see them. Have a conversation with them and understand what their issues are. And you may be creating mass amounts of work for them that could be eased with a simple change in the way you do your work. And similarly, there might be a simple change in the way they do their work that might make your work easier. So building partnerships and bridges and getting to know those people who are actually doing that labor would be really valuable. One of the projects that we did in the social sciences and humanities, a paper a year or two ago on the stewardship issues, I worked with DANS, the data archiving center in the Netherlands. It's one of Europe's biggest, most successful archive, and has a research group as well. And I was there as a visiting scholar for a year and started asking them questions about who uses these data, who puts data in, who takes data out, what do the archivists do, what's the piece in the middle. And and they did have a good answer. Most archives don't, because it's very expensive and very hard to get out in the field to do that. So Andrea Scharnhorst, the head of research, and I ran the logs with the help of Hank Vandenberg and some others, and Andrew Trelaw, to figure out who those people were, to try to get some sense on logs of who was contributing and who was retrieving and who was working with them. And then we covered the Netherlands. We went by train and bus and car and taxi and covered the country, trying to find these people and talk to them. And they had very different relationships to that archive than they knew. The archivists themselves felt like they're spending about half their time with the contributors and half with the retrievers. But it was the contributors that had a personal relationship with the archivists. The retrievers did not. They had no idea who these people were and what kind of work was going on in the background. We also found that the data were being used for very different reasons. We thought they were being used for research purposes, and they were being used for museum exhibits. They were being used by local tour guides who are printing them out, putting on plastic sheets of paper and walking around in a Dutch rainstorm to show people old archaeological mounds. So the project helped these different groups get to know each other and whose work was affecting whose work along the way. I think building that larger set of relationships and collaboration should not only bring that infrastructure up, it'll make them visible, and should make everybody's work better if it's done well. People like to be valued.
Yeah, Christine, I love that answer because I do think, identify or appreciating the relational component of the ethics of our work, right, is something that I think a lot about, and I feel like that that hits on that very heavily, right? That we shouldn't think of data scientists as sitting alone in their room, like doing their thing, right? We're all in this relation together, and acknowledging and valuing and investing our own time in that, I think, is a great answer to like how we might be good allies in this way. And there's a question from our audience too about what are your thoughts on at Curate Science and the ranking of authors on transparency practices.
So the question is, so it's a value, like an alternative metric, an alt metric on transparency.
I'll just acknowledge I'm not entirely familiar with it, what the Curate Science is, but I think we can think of it as a question on sort of how, evaluating ourselves, right? And, on a different metric, right? Not just publications, but transparency.
So I don't know Curate Science as a particular, I know a number of the altmetric sites, which are very useful, and Authoria, which is another platform that was launched by Alberto Pepe, who also was a PhD grad out of my group, have tried to do some of that kind of ranking for open science. The difficulty is the metric. And that's why I just sort of pushed aside that whole question of citing data and citing software, because the fact that we don't agree on what are the data leads to, we don't agree on how to describe the data. What kind of metadata, what do you put, what's a title that you put on a data set that allows you to find it again. And when you start to measure what is openness, is it the proportion of papers that people put in archive or in some other preprint server? Is it the number of data sets? And then you start, there's a risk of gaming it, of how many data sets versus the quality of the data sets versus the reuse of the data sets. And the question of the reuse, is it reuse for integrative purposes? Is it reuse for comparative purposes? Altmetric, bibliometrics is really problematic. We all know that. Altmetrics is problematic in other ways. It's a difficulty of agreeing on metrics, and then also what I mentioned before about the different cultures between fields. To say a paper with 2,500 authors, if you've been cited as one of 2,500 authors, that's probably different than being cited as a sole author paper. So, and there's lots of ways you slice it and dice it. We've got H indexes, we've got G indexes, we've got Erdos indexes. Take your pick. So I think it's a good trend if it gets people to think about their openness practices, yes, but coming up with a clear metric, I would not want that in a 10-year review.
Yes, I think we at least have to be very thoughtful about how we start measuring things and not reifying them in certain ways. There's a wonderful question here from Luis Felipe, who identifies himself as a longtime fan of your scholarship. So I wanted to share that lovely, talking about community data stewardship. For example, how funders are pushing some disciplines to co-create knowledge with Indigenous communities. And do you have examples of positive collaborations that involve experts and non-experts?
Of co-creation. It's not an area that I much work in, but I do have two colleagues in my department at UCLA, and Gilland and Ramesh Srinivasan, who both work in that kind of co-creation area. So I would refer you to their work. But it's definitely an important set of topics. I think it relates to what we just said about working with your community that's managing those data. If you really want to organize community archives well, you need to understand who the community is and how they think about what those entities are. And similarly, as we do a deep dive into astronomy or environmental sciences and try to understand what are data to them and when, it's a similar set of issues and approaches of you've really got to have domain knowledge. And whether we're talking about an indigenous community and what their domain knowledge is and what their cultural practices are, or we're talking about radio astronomers, you've got a community that just has a set of practices that may go back a very long time in how they think about what those artifacts are and what they value. So the ethnography and working with them, the qualitative work, I think, is really essential in data science, and it's been undervalued. And so another reason I'd send you to the Harvard Data Science Review. That piece of mine on the lives and afterlives of data is it's a triplet in the opening, the volume 1, issue 1 of Harvard Data Science Review by 3 women. Sabina Leonelli, who's a philosopher, and Jeanette Wing, computer scientist. So the 3 of us together riffed on what we think are some of those fundamental questions about what are data. And it's just different ways of thinking about them. And you can see the information science, philosophy, and computer science perspective just in that pairing, those 3 short pieces. So yes, co-creation is where we're at. So.
I want to take us a little bit in a different direction. We have a question that sort of about thoughts around industry and academic partnerships, particularly given sort of new evidence-based focus amongst our new Biden administration. And I actually want to add a little bit more to that, sort of thinking about these potential bridges between academic and industry efforts. On the research side as well, we've got a growth of efforts to build those partnerships. My own area in the social sciences, we have Social Science One initiative that's gained a lot of traction, which with the hope of opening up commercial data for research use, right? Your more integrative reuse kind of case, which is both really exciting and potentially a source of tension around issues of data sharing, reproducibility, the fragility, right? And the ability to sustain that. And even, I would say, maybe research equity and ethics. And so I'd like to ask what you think we should be thinking about now as individuals in or planning to be in industry with ties to the university, or as researchers with ties to our colleagues in industry. What should we be thinking about now to help ensure these don't create frictions or interfere with the principles of open science and the maintenance of knowledge infrastructures?
It's a very timely question, and thank you and to the questioners for that. The place to start is at the beginning. You want to talk through these issues at the beginning of the project, not at the end of the project when it becomes time to release them, and that be the time when you realize you had very different assumptions about who owns, who controls, who governs, what are the privacy issues, what are the ownership issues, is it going to be Creative Commons, is it going to be CC BY, how is it we're going to release these? For starters, universities, at least in the US, tend only to accept projects that are open and publishable. The publishable used to mean just the articles, not the data. So now we have to think about whether that partnership includes making the data set open as well. So those are things to be worked out. And there's definitely plenty of folks who are trying to do that. ICPSR, the Inter-University Consortium for Political and Social Research at University of Michigan, which is one of the largest and oldest social science repositories, has been working on opening administrative data. So the sort of bureaucratic inside data, that's another kind of thing that's been very closed. They're trying to make open for research purposes. And they're partnering with GESIS and in Germany and with the UK Data Archive and trying to do some openness there. Ann Washington at New York University is doing fabulous work in opening government data and the kinds of openness and the very different views on those data and how things like data.gov could be used and other kinds. I think that work we very valued in this new administration. So I think that's definitely where we need to go. But it's a frontier. We got into the open data questions 20 years ago when it was like, what do you want to? Not interesting. And it's turned out to be incredibly interesting. And because we got in so early, we had a much better sort of big picture view of where these are. So make that one like question 1 when you start that collaboration, not question 27 before you wrap up the project.
Wonderful, thank you. I want to share a question from our data science school as Provost, I'm not sure what, Phil, your title is, head, both thanking you for a wonderful talk and asking, is there more we might say about the role for university libraries and data librarians beyond our current status quo, maybe 5 or 10 years from now? Are there roles that we should be looking towards or building skills for?
Oh, thanks to Phil, big fan. Phil and I go back a long way, as you probably figured out by now. Yes, we need to be investing much more in data librarians, data archivists as a whole career track. And universities have been hiring maybe 1 or 2 in something the size of UVA, the size of UCLA, where given the scale of the challenge and given how deeply embedded in the research process managing these data are, we need a cadre of data librarians and data archivists at least comparable to the cadre of research software developers that we have in universities, because this is where the future is going, and you want to be able to reuse those data over the long period of time. Hubble, Chandra, Sloan, and others are very proud of the fact that more papers are now coming out of the archive, of data from the archive, than out of new data from the observations. And this is certainly where we'd like to go, not only in the sciences, but the social sciences. The digital humanities are thinking, they're thinking through these same kind of questions about who's going to maintain them. So we need people with the solid background. If you've got a bachelor's or a master's in a subject area, it's something you love, but you don't want to go on for a graduate in that area, you don't really want to be a full-time researcher, and you're interested in the data, we need to recruit a whole new cadre of people into the data science programs who bring domain knowledge, and then we can put them back into those domains and move them through. There's room for them in industry, there's room for them in government, there's room for them in universities. And yes, I think it should be a real growth area for the School of Data Science at UVA, at UCLA, at Michigan, at Berkeley, at other areas that are really investing here, Washington as well. So more power to UVA, to Phil, to Michelle, to Arlen, to all of you in building up these programs. And I've got a couple of my grads who are at Michigan and Toronto too.
And I think that is a wonderful invitation to, folks who with us today who aren't quite sure, interest in data, but might not know where they fit, like to think about these other layers of data science, right? That we really do need to, that also need more experts. And I want to thank you, Dr. Borgman, for helping us all think about whether we're in academia or industry or the public sector, particularly as we just referenced some of the partnerships that we might be able to build across these institutes, that we should be thinking about our role in helping to promote, right, data sharing and data reuse, data documentation and data management, that it really does take a village, right, is I think one of the takeaways of this knowledge infrastructure. And I want to sort of reaffirm that and thank you for helping us all think about that and how we might fit into that. We are at time. And so thank you so much for this talk. And I believe I am now kicking us off for a few brief videos that will precede our next session. And I hope everybody will stay with us and to learn more throughout this day. Thank you so much.